I believe we all now know how to configure RIP. So in today's lesson, we are going to look at Eigrp, our second and final distance vector routing protocols. And I hope we understand what you mean by distance vector routing protocols compared to link state routing protocol. And in a nutshell, just so that we are all on the same page, so if you have a network, these circles that I'm drawing are supposed to represent routers. Say we have router 1, 2, and 3. So let's say that we have a backup link to let's say this router connects direct to this network. Yeah. So a distance vector. So let's say that we have a network here, X, the network in question. A distance vector routing protocol defines a network. So like for instance, if you were to look at that network in question from the perspective of R1, R1 will say that I know about network X, which I learned through router 2. So, and if it is RIP, router 1 will say I know about that network. It is 2 hops or 3 hops away here. So like in this case, actually for RIP, it will choose this path, yeah, because it will see that I'm learning. So let's say this is router 4. You see that I'm learning about network X, and I'm learning about it from both router 2 and router 4. So router 4 is telling me that it's just 1 hop to reach there, but router 2 is saying for me to reach that network is 2 hops. It will cost me 2. So the vector here is 2, or the cost. Yeah. So what you mean by distance vector? Vector is the direction. Yeah. The distance is the cost. So maybe to understand that better, slightly better, is for a link state. This is where I said that when a router boots up, that is running a link state routing protocol like OSPF, the only one we'll look at in CCNA. ISIS, that's usually run in ISP networks, and it's not very common. So when you look at OSPF or link state routing protocols, the reason why they are called link state is they define networks in terms of the link state. Yeah. So like router 3, when it boots up, if it is running OSPF, it will create what we call an LSA, a link state advertisement. Basically, it's just a packet that have all the stats of the network X with regard to what router 3 sees. Yeah, so it will say I know about network X. It have the subnet mask. This is the network type. You know, we have various network types. It could be broadcast, point to point. So all those stats, and what things like bandwidth. Bandwidth is a major, you know, is a major link state factor that you need to factor, that needs to be carried in that packet. Yeah. So once it creates that LSA, it floods it to the neighbors that are also running the same daemon of OSPF, because all the routers have to be speaking the same language. If you go back to the OSI model, for communication to happen, they all have to speak the same language. So anyway, so when they get those LSAs, if they are running OSPF, of course they'll be able to process that. They'll be able to run SPF algorithm, and so essentially when router 1 gets, say, that LSA from router 3, it will know exactly what router 3 knows. So that way it can make a wiser decision. That's why we say that link state routing protocols are like road maps, because you see, if you're looking at a road map, it will show you whether this is a super highway, it's a class what highway, and all that. Yeah, because you see, RIP might choose this route, yeah, the one that is 1 hop, but suppose maybe the links between here are all fiber cables, and with gigs and gigs of bandwidth, RIP will still choose this because it defines the network in terms of distance and vector. Yeah, I feel like I've taken a lot of time explaining on that, but anyway, so here we're just looking at the various classifications so that we can appreciate the routing protocols, the various routing protocols that we have. So another thing that you need to keep in mind, we have looked at RIP, and so they are usually easy to configure. They don't need so much technicality to deploy it in a network. Though truth be told, if same of course you can say that it doesn't have many features. So truth be told, if you walk into any major network, you'll not find, if they have opted to run routing protocols, you'll rarely see RIP. Yeah. So Cisco previously used to call Eigrp as hybrid. That's why I have this, but this term is no longer applicable. They like to call it now advanced distance vector routing protocol because they don't feel okay to put Eigrp in the same class of RIP and Eigrp, some of those legacy protocols. In the Eigrp, when you talk about Eigrp and OSPF, these are the darlings of the industry, that wherever you'll find people deploying routing protocols, those are the two major that you'll find them deploying. So Eigrp, in my opinion, is arguably the best, were it not for the Achilles heel that it is Cisco proprietary, meaning that if you have a Cisco router connected to a Juniper, connected to a MikroTik router, you cannot run Eigrp. You have to go with the industry standard OSPF or those link state routing protocols. The problem with them is you'll need more knowledge to deploy those link state routing protocols, as in they are featureific, but just like an expensive Ferrari or a Dodge Viper car, you know that you have to, it gives you features, speeds and all that, but it's a high maintenance car. So likewise with OSPF, and by high maintenance, I don't necessarily mean that if you have deployed OSPF, that means that you'll always be troubleshooting OSPF. So that's, by high maintenance, I mean, there's a lot of nuts and bolts that you can fine tune on that protocol. So anyway, I think I've belabored on that enough. So I was saying that I believe you are now okay with RIP, because so long as you can be able to configure it, disable auto summary, if you can be able to do all this, you're good. So let's see how we configure Eigrp. And without further ado, because I've taken way lots of time on that, we'll use the same topology that we borrowed from our very first lab that we submitted to come up with this whatever. In fact, with Eigrp, I'm going to add another link just so that we can appreciate some other concepts that we will look at about Eigrp. So I've just added a backup link, yeah, to whichever of these two networks, such that if, say, router 3, the wiring closet there, everything, the fuse there blew up and that whole closet is down, there is actually in that case not the router going down, maybe it's the fiber cable with this, or the link goes down, yeah, R1 would still be able to reach R3's LAN using a backup. Anyway, I'm explaining what we all can see. So let's get to it. So configuring routing protocols, and I think I've mentioned this enough now. It's just the same way. You just go to router, and this is where when we do a question mark, we can see the OSPF, RIP, ISI, but here we are at Eigrp. And unlike RIP, where we just hit enter, if you do a question mark, you have to put autonomous system number. So this one, for Eigrp, I would say this is is not a very intuitive name they gave that number. Yeah. What I mean by that, I mean they should have called it a process ID. Yeah. You see, if it was OSPF, it's the same number, but is a process ID. Basically, what that is just creating an instance. Yeah. I'm typing RIP. Need to get back to Eigrp. It's just running a routing instance. What I mean by that is if we hit enter, when you say do show IP protocol, because that's how you see using the do command. I believe we know I should have exited to execute the show whatever, but from there I can just use the do command. So you can see that the routing protocol or the instance of the daemon that is running is Eigrp1. You can be crazy and turn several daemons. If you type do show IP protocol, you see now we have 2 routing instances going. Of course, Cisco or any other, as in it's not recommended to have more than one routing protocol on your device, not unless you have a very good reason for that. And usually there isn't none, not unless you're doing redistribution, which is a CCNP level topic. So anyway, just type router Eigrp1. So for Eigrp, this autonomous number have to match, yeah, in that if I create router Eigrp1, if I go to router 2, I have to create router Eigrp1. But for OSPF, these numbers can vary, but typically when people decide to deploy these networks, you don't go changing them on the various routers, because if say you have, if say maybe you're managing, let's say that you're the network admin of Huduma Kenya. I know they have like over 47 routers, because you're talking of 47 counties. You have a Huduma center in every county. So if you have 47 routers and you're, although that can be a good coding, like if this is where maybe you'd say county number 1, so maybe you have router matching to those numbers. And anyway, I think I'm digressing. So we just stick to the same number. For Eigrp, we don't have an option anyway, so we do the same thing, no auto summary, because as much as Eigrp borrows from both worlds, as we can see, it is the best of both worlds. Yeah, I'm saying that is one of the best routing protocols because it is simple to configure, as in it is easy to configure like a distance vector routing protocol, yet it behaves like a link state routing protocol. It behaves like a link state in a way. We will see, I will expound more on that in a bit. Alright, so up to there we're the same. Then we do the network command. And as a side note, the network command does the same for all routing protocols, yeah, as in it has 2 functions, meaning that if you are on whichever router, yeah, so you can see here we are under the router configuration mode. So this is where we have gone conf t to go to global config mode. Then you type router, say Eigrp or whichever routing protocol. So the network command, it has the same function as in other IGP routing protocols. That's what the first bullet there says. Yeah, so like in our case here of this topology, so it seems the network admin here on this whatever is in router 2. So they have typed network that dot. So what the network command does is any interface on this router that matches the network address in the network command will be enabled to send and receive updates. I don't know whether that so in this case you can see that 192.168.10.0 is this network here, because this interface matches the network command. Yeah, there is no other interface that matches that network command. Yeah, because you can see this doesn't match, this doesn't match, and this doesn't match, because in this case we are looking from the perspective of router 2. So every interface that matches the network command is essentially added. So if you start now doing packet sniffing, if you do wire share capture on that wire, you'll see Eigrp or whichever other routing protocol you're running. Yeah, you'll see activities there. Yeah, so that's the first function. So here actually I should have bullets. So number 1, the circle there. So number 2, point number 2, or what the network command does is the network or subnet that will be included, or subnet will be included in Eigrp routing, meaning that this network now, my router 2 will become a gossip girl and will start gossiping. Hey, I know about this network, I know about this other one, and all that. So those two functions, in fact, you might find them in an exam environment. In fact, if you are doing the Cisco Networking Academy program, where after every module, you know that if you were to, or the way we, after every module, there is an online assessment that you're supposed to do, so that after every module, after CCNA 1, CCNA 2, CCNA 3, CCNA 4, there is always a final exam. All those internal exams to the Cisco Networking Academy, of course, they are all to prepare you to, for you to get used to, so that when you go to the Pearson VUE site to, to do the exam, you're familiar with that. So anyway, without much digressing, let me come back to where we were. So we now understand the network statement, what it will do, and that's why I was saying you always want to do a show IP interface brief, yeah, so that you can see the interfaces that you have. Because when I type network 192.168, that one there, of course in this case it'll just be like that, .0, because it's the whole network, although yeah, it's the whole network like that. So when I hit enter, this particular network, my R1 will start gossiping about it to the neighbors. It will tell the neighbors, hey, I know about this network. And so now fast Ethernet, this one here, because it matches to this, or is a usable IP address in this subnet. So there'll be, because it's part of this network, there'll be activities on this, and this is where the passive interface was coming about, because we have F00, so it matches. So of course later we need to configure this link as passive, because you'll start sending packets out F00 and they are of no use, they're wasting bandwidth, and it can be a security risk. So, and this is where you can use your summarization, or what we call supernetting. Okay, actually there's a slight difference between summarization and supernetting, but summarization is where you have a couple of subnets, yeah. So like, let's say you have your router there that have several links, yeah, several networks to the various whatever. So let's say here you have 192.168.1.0/27, then you have .32, just like what you had subnetted, 64/27. There's a way you can summarize all this, so that you just write one network statement. In fact, some of the advanced features that we will look at Eigrp are because Eigrp is fine tunable, just like I think anyway, I think let me not jump ahead of what we will look at later, but you can do summarization. So summarization is just advertising all these networks as one, and the way we actually do it is you write these networks 192.168.1.0 in binary, then you have 192.168.1.32, then you have 192.168.1.64. So we know that if we convert this to binary and this and this, we have 24 bits that are the same, yeah. So there's no point of, because I think let me first do it so that you get what I'm trying to get at. So if you just take the last octet, because we can see this is where the changes are happening because for all these other, the first 3 octets are the same. So so we have it, maybe let me just, you have 192.168.1, but the last one you can just write it in binary. So we have 1 2 3 4 5 6 7 8, then you have 192.168.1.32 would be 0 for 128, 0 for 64. We have what is hard writing it in that, I believe it's something like that, if I'm not wrong. 192.168.1 dot, so we have 0 1, I believe, so we have something like that. So with the summarization is where you spot the difference. Yeah, I have said here we have 8 bits that are all the same, 8, so that's 24 bits that are the same. Then we can see right here, in fact, if I could draw it with another color, right there we can see is where we are spotting the difference, because so essentially we have 25 bits that are the same. Yeah. So to know a summary route, a route that we can advertise to the rest of the neighbors without advertising individual subnets, is so once you draw this line, you copy or you record all the bits that are the same. So in this case we have 25 bits that are matching. Now with everything to the right, you turn it into 0 and then you convert back to decimal. So if we turn everything into 0, we'll have, and we convert back to decimal, we'll have 192. We are assuming that these ones we had converted to binary, so you have 192 now back in decimal. You have 192.168.1.0, because if you convert everything to the right, it will be all zeros, and then you take the record of /25. So if we take all these /27s, we can advertise them as 192.168.1.0/25. So that's what we call summarization, which essentially you can see is like the reverse of subnetting. So essentially here is like you have subnets or child routes, you advertise them in mother route. Now summarization and supernetting sometimes can be used interchangeably, but there is a slight difference. Now what we have seen here is what we call summarization. Supernet is where you take classful IP addresses and you summarize them. So maybe this is where you had 192.168.1.0/24. So we know that that's a class C that have never been subnetted. Let's say we have 192.168.2.0/24, .3.4, like that, and we want to summarize. So of course we'll take these first 8 bits, so 24, that are essentially the same. So at the third octet, that's where we'll convert them to binary, and we repeat all that. So of course we'll get one summary root that is lesser than the classful subnet mask. So that's what we call supernetting. So supernetting is going beyond the default classful subnet, but otherwise the process is the same. So basically we can say that supernetting is essentially summarization. So not all summarization is supernetting, but supernetting is definitely a summarization. I hope that makes sense. And I have way digressed from this. So anyway, we're at the network statement. Now we need to do the rest, and this is where you see the power of summarization. The way we have hit that, we can take care of this, of all this. In fact, if I can remove that whatever, you can do network 192.168.1.0 with Eigrp. You can choose to configure it simply as we were doing with RIP, yeah, the simple, the low maintenance Kevo's car here, right? The one that a reliable manual car that doesn't have a lot of complications, high maintenance and all that. So you can choose to run it simply like RIP, or complicate issues like OSPF, because with the OSPF you have to put these things called wildcard mask, and all they are is like a subnet mask inverted, yeah. So like in this case you would do 0.0.0.255, and what this is or to calculate those wildcard masks, you take all 255s, as in you have 255.255.255.255, you minus your given subnet mask. So you have 255.255.255.0 if your subnet mask is that, so then you get 0 if you minus, so you have 0.0.0.255, yeah. Now why did they choose to do that? Just because we don't know. But you see what this is, wildcard masks, and you'll see them a lot, and I think we saw them in NAT. I don't know, I'm forgetting whether I explained it. So it's just an inverted subnet mask, but in this case where you have a 0, it means the matching octet in that position is significant. So yeah, by 0 it matches all that. So in fact, this is what we say, that these advanced routing protocols, they let you to be granular, yeah, in that let's say that R1 had, say, another subnet connecting to the research and development or some sensitive accounts server that you don't want R1 to gossip about the rest of the network, yeah. In this case, instead of doing maybe 192.168.1. like that, you can even do per interface. like you do .1, then you do 0.0.0.0, like that. So if you do that way, where you have a 0, it means that this have to exactly match. This have to, where you have a 0, it says it is specifically, so that one have to match, yeah? So in that case, if I hit enter, Eigrp will run specifically on this interface. So you can be that granular. You choose which interfaces you want. And if you combine with your summarization skills that we have just seen, it means that if say this router had like 5 links, you can choose just 3 links to run Eigrp, and the rest are just you know. So all these are tools at your disposal. So here we can say 255, and if I hit enter, it will take it, but it knows that even if you have a 1 here, so wherever I have a 255 or 1s, yeah, where the bit positions are set, they are all 1s, that's a don't care position, so it doesn't care. So in fact, if I say do show run, we can do section router, just to see the, so you can see that I typed this, it is taking that, yeah. I hope I've made sense on that, but I believe by the time we look at NAT, and let me try to find our bearing on where we are. So you know that this is CCNA2, yeah, routing and switching essentials. So essentially we have jumped to CCNA3 to look at Eigrp, but we will not look at OSPF. We'll come back to CCNA2, so that then now we can just look at switching and all that, yeah. So that's that. So I think I've configured all the networks apart from this one here. So 172.16.1.0, enter. So let me just opt to configure it as simple as RIP. So with that, maybe the next thing that you might want to follow are things like passive interface F00. Of course, we know what that command does. So I think in this video, looking at the time, we'll just configure the basic vanilla whatever version of Eigrp, so that then we'll come back, and in the next video is where we look at, I will delve deeper into it. Alright, so we can do that. Go to router 2, global config mode, router Eigrp 1, and this is where you need to see what you have. Check your routing table, because you want to turn router 2 also to turn on the, yeah. And you see, after turning on the daemon, so router 1 and router 2, right now they are both speaking the same language, but because of the network statement, the daemon here doesn't know what to advertise. You haven't specifically defined what it needs to advertise to the neighbors. So let's make it happen. We can just harmoniously advertise all the networks. We have 192.168.1.0. For the fast Ethernet, this one here, it's our quote unquote public IP, yeah? Because this is the one that connects with the ISP. It's private, of course, because it connects to the LAN, to my network here at home. So but you get the point. Yeah, so normally we wouldn't advertise the public IP address here, but this is private. And I think I showed you how to configure that in the previous. So anyway, you can see that unlike RIP, Eigrp is reliable. So in fact, these are some of the things that we'll see in the concepts in the next video. Is reliable, yeah. So unlike RIP uses UDP communication, but Eigrp, so you know that at the transport layer we have TCP or UDP. So for RIP, we say that after every 30 seconds it just floods to the neighbors its whole routing table, but of course obeying the split horizon rule. The split horizon rule is where I said that if you have your network here, and you have, say, your router 1 and router 2, so router 2 of course will have advertised to router 1 about this network here. So when router 1 is sending its periodic update to router 2, it will not include this network. So split horizon rule says do not tell your neighbor what they have already told you, and that's a routing loop prevention mechanism, just like what we had, things like TTL. Okay, without digressing, Eigrp doesn't use either TCP or UDP. It has its own reliability mechanisms. So in fact, to see it, because I think we have turned it on all this because we are on router 2, so we have enabled it on all that, but for we can actually start a Wireshark capture anyway to see the packets. Of course, they'll be able to explain more of what I'm trying to get at maybe later. So you can see that the various types of packets that Eigrp uses. Now, for these routing protocols, and some of the things that we need to commit to our mind are things like the multicast IP addresses that are used by the various routing protocols. For Eigrp, it uses 224. Remember when we did the class A, B, C, D, and E, I said that we use up to C, but D is where if you use that internet gods rule, you'll see that it's within the range of 224, I think, up to 239. Yeah, so you can see that anything 224 is multicast. Multicast is and I think you have seen this in the notes. So the various types of communications we have on our networks, we have multicast, unicast, and broadcast. So broadcast is flooding the message to everybody in the network. So this way you have things like ARP, DHCP discover messages, and this is one of the reasons why we want to do subnetting, so that you can segment your network. So in fact, Cisco says you should never go more than 500 devices in your LAN, because the amount of broadcast traffic in that LAN will be crazy. I think of things like ARPs and broadcasts like the cloaking of frogs in a pod. So you need to segment your pods, because the cloaking of the frogs there can be deafening. So for unicast is 1-to-1. So whenever you go to Facebook, of course, you have your computer, right, or Google or whatever that communicates to Google server, Facebook. So that's a 1-to-1. That's what you say, unicast. So for multicast is 1 to a group. So the typical applications would be where maybe you're doing, say, like an online video where you have several clients. Let's say you and I, we have tuned into with our laptops here. So multicast would be one to a group. Of course, to make better use, because if you use broadcast, that would be chaos, because everybody else who have not tuned into this online radio, they'll be bothered by that traffic. Yeah. Anyway, I hope you follow on that. So anyway, I think we will review this more in the next video, so that we look at these various concepts. Now let's finish configuring so that we see the reliability mechanism. So we are done with router 2. We go to router 3. So we do router Eigrp 1. We do no auto summary, and actually we did not do did we do auto summary on router 3? Think not. Now do S just to see what we have, so we can harmoniously enable Eigrp on all these 3 interfaces. This and that. Of course it cannot run on that, because first of all, even that interface is down. There's nothing connected there. So my network 192.168.1.0, hit enter. Now we can see a neighbor relationship that forms, and if we come back to Wireshark, a lot of stuff have been happening. Did we see? I need to do capture stop so that we can do a bit of analysis of the packets that so we have the hello packet. The work of the hello packet is to discover neighbors and maintain and a keep alive mechanism. It's a keep alive. So unlike RIP, that is a bit unreliable, so every 30 seconds you're just flooding without knowing whether your neighbor is online. And you see, that way you waste bandwidth because you're sending the whole routing table. These guys don't send, if you're running Eigrp or even OSPF, as you'll see, they don't broadcast the whole routing table even if there is no network change, you keep on sending the whole table. That's inefficient. So they just keep they send these lightweight packets for Eigrp by default is every 5 seconds. Hello, you're still there. So you're still there. We just refresh our routing table. So you have the first packet you have is hello packet. Now after they discover each other, I think this is where now I configured. So there is an update packet, and you can see there is an ARC, update ARC. So another packet that is not seen here is a query packet. To see the query packets, I can do the same capture again, and we are now venturing into the other to the concept. So I need to be on R1. A query, of course, just like the term suggests, is say if my router 1 loses connection to F00, somebody have tripped on the wire as they were, or something, maybe the switch here just blew up, and it have lost connection. So of course the link there will go down, and that's what we are simulating here. We say shut down. Now router 1 right now is sending queries, trying to ask the neighbors, I've lost connection to this, do you have a backup and all that. So in fact, if we if you come here, you can see you have some query packets and you see every packet that is sent is acknowledged. Now Eigrp have its own acknowledgement mechanism. It doesn't use TCP. Yeah, so in fact, you know, if it was TCP, you would see under protocol, you would see either TCP or UDP. But Eigrp, in a bid for the engineers behind Eigrp, in a bid for them to make Eigrp protocol independent, meaning you see right now we run TCP IP, but remember back in the days we had things like SPX, AppleTalk, and the OSI model. Yeah, so you have like 3 or 4 competing standards. So these guys wanted, if say the industry decides today we are going to run OSPF and OSI instead of the TCP IP, Eigrp doesn't need the TCP or UDP reliability mechanisms that are that are TCP IP whatever, yeah, part of the TCP IP protocol stack. So in fact, Eigrp, that's what we call PDM, protocol dependent modules, so that it can run in fact when the world, or when we go to IP version 6, Eigrp have no problem. You just anyway, I think I've belabored on that, just trying to explain those packets. Anyway, I think in the slides you'll appreciate what I'm trying to say here. So let's restore the network. So I think the next packet that we have not seen is of course the update packet somewhere, if you're still capturing. Hello, we have a reply. Anyway, I think we'll review on those. So anyway, looking at the time, I think we'll put a break there, and we will discuss the other concepts in the next video. So that, I hope this have been informative to you, and I'd like to thank you for viewing.